In the previous session, we have seen how to find the modulus of a given number and how to apply Euler's theorem to find out the phi of a function, isn't it? So now we'll go one step further. We'll see what are the applications of Euler's theorem. See, this topic is very important with respect to the exam. So in the final exam, they'll ask a question like this. Find the last digit of 7 to the power of 1000. They can also ask the question like this. Find the last two digits of 7 to the power of 1000. So this number is very huge, isn't it? We cannot keep multiplying 7,000 times and we cannot get the answer. That is impossible, isn't it? That's very difficult. So how do we solve this problem? So we are going to solve, see, this problem is an application of Euler's theorem. So we can apply Euler's theorem and we can solve this easy. So how do we solve this? We will see. See, we already know that, see, any number, see, for example, I'll take the number like this. Let us say the number is 124. So what is the last digit of 124? The number is 4. See, 4 is the last digit of 124. Everybody knows. So how did we find out this one? So there is a simple way. See, any number, if you want to find the last digit of that number, you just divide that number by 10 and you take the remainder. See here, if you divide 124 by 10, and what is the remainder here? The remainder is 4. Isn't it? So any number, if you want the last number, last digit, you divide the number by 10 and you get the remainder. Isn't it? And if you want the last two digits, let us say, the last two digits, instead of multiplying by 10, dividing by 10, we divide it by 100 and we take the remainder. See here, if we divide 124 by 100, so what is the remainder here? 24. So the last two digits are 2 and 4. So same principle we are going to apply here, isn't it? So before applying that, so before applying this problem, before going to solve this problem, we need to understand two basic formulas here. See here, if GCD of a comma n is m is 1, then we can write it like this. See here, once again I repeat, if GCD of a comma m is equal to 1, then it can be written as a to the power of phi of m is congruent to 1 mod n. See, these two formulas are very important in such kind of problems. Okay. So now, so how do we solve this now? So let us go ahead and check. Okay. So in this question they have asked, find the last digit. We have to find the last digit of this very huge number, isn't it? So first what we'll do, so we already know, once we speak about the last digit, we should divide the number by 10, isn't it? As I showed you here, we should divide the number by 10 and we should take the remainder. So first we'll apply the first formula here. Okay. Since we are dividing the number by 10, see, what is the number here? See, 7. So first we'll find out whether the GCD of 7 and the GCD of 10 is equal to 1. So you can go ahead and find out. So you'll find the answer as 1. Okay. So this is satisfied, isn't it? So the first formula is satisfied. So what I can write here? See, in place of a we have 7, in place of m we have 10, isn't it? So we'll substitute this formula. See here, in place of a we have 7, in place of m we have 10. So here, so 7 to the power of phi of 10 is congruent to 1 mod 10. Okay. So from this formula I got this one, isn't it? So I just substituted. So in place of 7 I have a, in place of m I have 10. Okay. Then, so how do we find phi of 10? In previous problems itself we have seen. See, phi of 10, I can express 10 in terms of two relatively prime numbers. Two relative prime numbers means the GCD of these two numbers should be 1. So you can go ahead and find, see, the GCD of 5 and 2 is 1. So I can express 10 as phi of 10 as phi of 5 into 2. So I'll go ahead and further simplify. So I'll multiply phi of 5 into phi of 2. Since this is a prime number, I can just subtract this by 1 and I can get the answer. So phi of 5 is equal to 5 minus 1, that is 4. Phi of 2 is equal to 2 minus 1, that is 1. So 4 into 1 is 4. So what is phi of 10? Phi of 10 is 4, isn't it? So here, now I am directly substituting it. So 7 to the power of phi of 10. What is phi of 10? Phi of 10 is 4. See here, 7 to the power of 4 is congruent to 1 mod 10. Okay. Now if I take the mod to both sides, 7 to the power of 4 mod 10 is equal to 1 to the power of, 1 mod 10, isn't it? See here, the question is, they have not asked what is 7 to the power of 4. They have asked What is 7 to the power of 100? See, we don't know what is 7 to the power of 100, isn't it? That is very huge number. So how do we do it then? So what we'll do is, so we'll express 7 to the, we'll express 1000, the power 1000 in multiples of 4. See, because we know the answer for 4, isn't it? So what is 7 to the power of 1000? See, if you multiply 250 into 4, we'll get 1000, isn't it? So 250 into 4 is 1000. So that's why I know the answer for 7 to the power of 4. So I am expressing 1000 in terms of 4. So 4 into 250 is 1000. So 7 to the power of 1000, how I can write? 7 to the power of 4 into 250 mod 10 is equal to 1 mod 10. See now, please listen here. See now, I already know what is 7 to the power of 4 mod 10. So that is 1, isn't it? See, 1 to the power of 250 is again 1, isn't it? So we got the answer as 1. In the same way, for example, let us go to the next problem. See, let us say they'll ask like this. What is the last 2 digit? Isn't it? What is the last, in the previous example we saw what is the last digit. See, now they're asking what are the last 2 digit of 7 to the power of 1000, isn't it? So again, you can go ahead and check. See, once we get the problem like this, last 2 digit means instead of taking 10, we have to take 100, isn't it? So what is the first we have to find out the GCD of 7 and 100. So you can go ahead and check. This GCD of 7 and 100 will be 1. See here. So I'm substituting this. In place of A I have 7, in place of M I have 100. So I've substituted this. So how do we find out phi of 100? See, here we have done it. See, phi of 100 I can write it like this. See, 2 square is 4, 5 square is 25. So 25 into 4 is 100, isn't it? So now if I go ahead and further multiply, see, you might be remembering one formula. Phi of 2 square is equal to phi of 2 square minus phi of 2 to the power of 2 minus 1, isn't it? So if I apply this formula here, see, one second, I'll show you that formula. See this formula. So which formula am I applying here? If you see here, so this is the formula I am applying. See here, phi of 2 cube is equal to phi of 2 cube minus 2 cube minus 1. So 2 cube is 8. So 2 to the power of 3 minus 1 is 2 square. So 2 square is 4. So 8 minus 4 is 4. So in the same way I am applying this one. Okay. So in the end I'll get 40 as the answer. So phi of 100 is 40. So what I am doing again, I'm substituting here. So what is phi of 100? 40. So 7 to the power of 40 is congruent to 1 mod 10. If I take mod on both sides, 7 to the power of 40 mod 100 is equal to 1 mod 100. See, you might be thinking, why didn't we take 10 here? Can you pause and think? See, because we are finding the last 2 digit. If they would have asked the question like this, what is the last digit? Then instead of 100 we would have taken 10, isn't it? See, now I know the answer. What is 7 to the power of 40 mod 100? That is 1, isn't it? But this is not the question they have asked. They have asked what is 7 to the power of 1000. So how do I express 1000 in terms of 40 here? Because I know the answer for 40, isn't it? So if you multiply 40 into 25, what you will get? Go ahead and check in your calculator. 40 into 25 is 1000. See, why am I expressing in terms of 40? Because I know the answer for 40, isn't it? So 7 to the power of 40 into 25 is 1000. So if I substitute it, I'll get, see, 7 to the power of 40, I already know, that is 1, isn't it? So 1 raised to 25, again it is 1 itself, isn't it? So the answer is 1, isn't it? So in the same way, so let us take a different kind of problem. See, what is the last digit of 55 to the power of 5? First, what we'll do, we'll try to solve this problem in the previous way. See here, what they've asked, last digit. Last digit means what comes to mind? So 10 comes to mind, not 100, isn't it? So first we'll find out, is the GCD of 55 and 10 1? See, go ahead and calculate. If you find out, so the GCD of 55 and 10 is not 1, it is 5, isn't it? So we cannot directly apply this formula here, but we have one small trick. See here, 55, can I write it like this? 5 into 11, isn't it? But and we also know that GCD of 11 and 10 is 1, isn't it? See, you might be thinking, why did I come directly to this? See, this one I'm going to use it in solving this problem. As you know, any two successive numbers, they are having the GCD as 1, isn't it? See here, in our problem we need to find out 10 and 11, isn't it? I need to express the problem in terms of 10 and 11. So 55 I can write in like this, 5 into 11. And we also know that GCD of 11 and 10 is 1, isn't it? So what I'll do, I'll write this one in terms of this one. in few moments you will understand why we did this, isn't it? So in place of A I have 11, in place of M I have 10. So what I'll do, I'll express this one in terms of this one. So what did I get here? 11 to the power of 5 of 10 is congruent to 1 mod 10, isn't it? So what is 5 of 10? In the previous problem itself we have solved. 5 of 10 is 4. So 11 to the power of 4 is congruent to 1 mod 10. So 11 to the power of 4 mod 10 is equal to 1 mod 10 if I take mod on both sides, isn't it? See now the question is, I know the answer for 11 to the power of 4. But what the question they have asked? 55. So we are nowhere near, isn't it? So now let us find out now. Now you will know why I express 55 like this. See here, how can I express 55? See, 11 into 5 is 55, whole power 5, isn't it? Now if I individually break it, 11 to the power of 5 into 5 to the power of 5, isn't it? So now, how can I express 11 to the power of 5 in terms of 4? Because I know the answer for 4, isn't it? So 11 to the power of 5 is 11 to the power of 4 into 11, isn't it? So now, what is 11 to the power of 4? The answer I know, it is 1. So 11 to the power of 4, 1 I'll leave it. So this 11 and 5 to the power of 5 I'll take. So 5 to the power of 5, what is 5 to the power of 5? You take your calculator. So you'll get 3125, isn't it? So 3125 into 11, what you will get? 34375. And in the end, if you do a modulus operation on 34375, that is if you divide it by 10 and take the remainder, you'll find out that the last digit is 5, isn't it? So in the same way you can find out last digit, last 2 digit, last 3 digit, isn't it? So same formula you can apply. Now let us go to one more problem. So this is also a different kind of problem. See, what is the last 2 digit of 3333 raised to the power of 4444? Isn't it? See here, once they tell last 2 digit, what should come to our mind? 100 should come, not 10. If they say last digit, then 10 should come to our mind, isn't it? So again, first we'll apply this formula here. See, is the GCD of 3333, 101? So go ahead and find out, it will be 1. So here I can directly apply this formula here, isn't it? So this formula I can directly apply. So this is what I have done. I have made substitution. So what is 5 of 100 from the previous problem itself, isn't it? We have seen, but anyhow I have written it here again. So 5 of 100 is 40. So 5 of 100 is 40. So this one I have substituted. When I take modulus on both sides, 3333 to the power of 40 mod 100 is equal to 1 mod 100. See now, I know the answer for 3333 to the power of 40, isn't it? But this is not the question they have asked. They have asked like 3333 raised to the power of 4444, isn't it? So now how do I express 4444 in terms of 40, isn't it? See here, this is what we'll do. We'll express, you see, if you multiply 111 into 40, what you'll get? You'll get 4440. So how much is remaining? 4440. If you subtract 4444, you'll get 4. See here. So this if you multiply this power, you'll get 4440 plus 4. Plus 4 if you add, you'll get 4 times 4, isn't it? See now, I know the answer. What is 3333 raised to the power of 40? So this becomes 1. So this entire thing becomes 1. And the only thing remaining is this one. So if you take your calculator quickly, you'll get 3333 to the power of 4. You'll get this one. And what is the last 2 digit? Last 2 digit means mod 100. See here. Last 2 digit, if you take it, this is the remainder. So the last 2 digits are 2 and 1, isn't it? Once again I am telling students, so this problem is very important with respect to the exam. Next, we'll take one more problem. What is the last digit of 3 to the power of 1000? So again, this is very easy, isn't it? So instead of, we have solved something like this. Previously in place of 3 we had 7. So once they tell last digit, what should come to our mind? 10. So we'll find out, is GCD of 3 and 10 1? Of course it is 1. So we'll directly apply this formula here. See here, we'll directly substitute it here. So if we substitute, what we'll get? 3 to the power of 5 of 10 is congruent to 1 mod 10. So 5 of 10 we already know, it is 4. So 3 to the power of 4 mod 10 is equal to 1 mod 10. So then we know the answer for 3 to the power of 4. So how do we express 1000? I'm sorry, this is a typo here. So there should be one more 0 here, isn't it? So how do I express 10,000 with respect to 4? So 2500, if you multiply 4 times, you will get 10,000, isn't it? So here, what is 3 to the power of 4? We already know, 1. isn't it? So 1 raised to any power is again 1. So the answer is 1, isn't it? So in the exam they might ask the question in a different way. Sometimes what they'll ask, instead of asking last digit or last 2 digit, they'll directly ask you to find out the value of phi. For example, we'll see. What is the value of phi of 256? See, 256 I can write it like this. 2 to the power of 8, isn't it? So 2 to the power of 8 is 256. So this, again, this formula I am applying here. See here. So this formula I am applying. See, 2 to the power of 8 is equal to 2 to the power of 8 minus 2 to the power of 8 minus 1. So 2 to the power of 8 is 256. 2 to the power of 8 minus 1, that is 2 to the power of 7 is 128. So 256 minus 128 is 120. Now again, so how can we express 255? See, in the exam if they ask what is phi of 255, see, we can express 255 as 3 into 5 into 70. If you take your calculator quickly, we'll find out 17 into 5 into 3 is 255. Again, if you take the phi value for individual function, phi of 3, phi of 5 into phi of 70. See here, all these are prime numbers, isn't it? See, if they are prime numbers means we have to simply subtract 1. Okay, see, 3 minus 1 is 2, 5 minus 1 is 4, 17 minus 1 is 6. So 16 into 4 into 2 is 128. So there is a typo here. So 2 into 4 into 16 is 128. So all these questions, they are important with respect to exam. So kindly study.